mechanical and fracture characterization of Epoxy-PLA, Graphene, SiO2 composites, and the contributing authors are given below. This work investigated the effects of addition of Graphene and SiO2 on mechanical and fracture properties of Epoxy-PLA nanocomposites. Nanocomposites were manufactured with varying contents of graphene and SiO2 by solution casting. FE analysis was also carried in order to predict the tensile strength of the nanocomposites by using representative value element in ANSYS workbench. The steps followed for the preparation of the nanocomposites are shown in the figure, and totally 6 samples were prepared with 5 nanocomposites and a pristine PLA epoxy composite. The nanocomposites were characterized using tensile, flexural and fracture toughness test to understand the effects of addition of filler addition on the properties of the composites. Tensile, flexural and fracture tests were carried in accordance with the corresponding ASTM standards by using the specimens shown in the figures. The results obtained are shown in the figure. As we can observe, as the filler concentration increased from 0.1 to 0.3, an increase in the tensile, flexural and fracture toughness was observed, and further addition of the filler resulted in reduction of the tensile, flexural and fracture toughness. This was attributed to the agglomeration of the fillers. The fracture surfaces from tensile test were studied using SCM to understand the effect of the filler addition on the tensile strength of the composites. The nanocomposites exhibited rough surfaces and cleavage planes compared to the pristine composite, and the figure E exhibited the agglomeration of the nanoparticles. FE analysis was used to predict the tensile strength of the nanocomposites, and the obtained results were compared with the experimental results. The steps involved in the FE analysis are: first, the material was created using material designer model, and the model of the tensile specimen was modeled. Then the model specimen was meshed and the boundary conditions were applied, and the analysis was carried. The tensile stress in the S3 specimen is shown, and the table shows the tensile strength obtained from the simulation and experimental results. The results obtained from the simulation and experimental are in close agreement with each other. And finally, the conclusions: an increase in the tensile strength, flexural strength and fracture toughness was observed with the addition of fillers from 0.1 to 0.3 weight%, and an increase in tensile strength of 29 to 60%, an increase in flexure strength by 5 to 57%, and an increase in the fracture toughness by 23 to 104% was observed. And finally, it was concluded that the Epoxy-PLA nanocomposites added with graphene and SiO2 exhibited better mechanical and fracture properties compared to pristine Epoxy-PLA composites.